We're going to look at something called CSMA-CA, which is a protocol designed to try and avoid collisions in wireless networks. So if you think about a wired network, we've got a great deal of control over that because the data is only going to go through the wires that we've made the network up of. When as soon as we make things wireless, on the other hand, we lose that control because if we imagine in this diagram, for instance, if we imagined A being, I don't know, a laptop or something that's wirelessly enabled, it can broadcast in a very wide sort of area, really. I mean, it's about 100 meters around in any direction, probably give or take. And that really sort of limits the control that we've got. What it also means is that we are opening ourselves to lots of potential collisions, because if we've got lots of devices all trying to communicate at the same time, you're going to get all sorts of problems in terms of collisions. So this CSMA-CA is a protocol designed to try and avoid that. And it stands for Carrier Sense Multiple Access Collision Avoidance. Okay, so if we break that down a little bit, the collision avoidance hopefully is obvious. What we mean by carrier sense, though, is each sort of node on this wireless network. So in this little diagram, I've got A and B would be nodes or computers or whatever we want to call them on this network, and they have the ability to sense whether or not another node is transmitting. And that's very important if we want to try and avoid collisions. Okay, so in this diagram here, A would be able to tell that B was transmitting or not. So if we have a look at how it works. So this is a little flow chart that goes through it. We go and start, and then we assemble this frame of data. So whatever we're trying to send. Okay, and then we're going to check using carrier sense if the channel that we're transmitting on is idle. If it is idle, so it's not in use, then great, we can transmit that frame, job's done, it's fantastic. If it's not idle, so it's fundamentally another device is transmitting, then we have to wait a random length of time and then essentially try that again and check if the channel is idle again. Now we wait a random length of time because if we just set a set length of time, then if two things were trying to transmit at the same time, they'd both end up just waiting the same length of time and it would get sort of stuck in a bit of a loop. Okay, now that's the basic version of this. However, that does have problems. Okay, so in its simplest form, it does have a few problems with something called hidden nodes. And this diagram hopefully will sort of illustrate what that means. So if we imagined in this diagram that A and C were computers connected wirelessly to a wireless access point, and let's assume that was B in the middle of them. So A is able to connect to B, which is fine, and C, as you can see from it as well, is able to connect to B as well. However, A and C can't really see each other. They are not within each other's ranges. So what issue this would cause is that if A was transmitting and C was transmitting at the moment, through their own carrier sense, they would not be able to tell if each other were transmitting. So they might end up transmitting at the same time. If they were both saying, right, I'm going to send something to B, that could cause some problems. Okay, so we need another way of solving that. And what we do is add something called RTS CTS into the CSMA CA protocol, sort of like a little bolt-in that we can add to it, which solves these problems with hidden nodes. So it works like this. Okay, so we've got a very similar looking diagram, really, in a lot of ways, at least. That we start from the same point where we've assembled this frame, and then we're into the same point where it's going to go, right, is the channel idle? And if it is idle, so if it thinks, so this node says, right, well, I can't sense anything going on here. So the channel, as far as I'm concerned, is idle. It will transmit something called an RTS, okay, which is a request to send. And that's sent to the access point. So in our diagram before that, we sent to B, which was this central point that everything was connected to. Now, what B will do, or what the access point will do, is it will then, if it is actually clear to send, it will then reply with a CTS signal, or clear to send signal. Then, if that's then received, we know that there are no hidden nodes transmitting at the same time, and therefore we can transmit that frame. If, however, A, the channel in the first place is not idle, so in the same way as we had with our basic version of this, Or if we do not receive a CTS signal back, then we go back and we wait that random length of time, and then we test again. And that process will continue in the same sort of way. And that removes this problem of having hidden nodes.